chemistry with this chapter as opposed to how to collect data. So this chapter focuses more on, we're starting to kind of dip our toes into the chemistry waters here. So you've probably seen these definitions before. Matter is anything that has mass and takes up space. It is a ratio of mass to volume, which is called density. So density is mass over volume. Matter is anything that has mass and takes up space. Takes up space means volume. Okay? So properties of matter, physical properties. Physical properties are easy to observe. They can be measured without changing the makeup of it. And there are two types of physical properties. Yeah. Bring in your toolkit tomorrow and you can fix it. All right, so two types of physical properties. One type is extensive and the other type is intensive. So extensive properties, extra makes a difference. So you ask that. If it does, then that means it's an extensive property. So you ask yourself, does extra make a difference? If I have one of these popsicle sticks and then I add 5 more, did the mass change? Okay, so extra made a difference. If I have one of these popsicle sticks and then I add 5 more, did it make a difference in the volume of the popsicle sticks, the total volume? Yes, then that's an extensive property. Did this change? Did the height of the popsicle sticks change? Yes, extra made a difference. So those are extensive properties. The thing about extensive properties is they don't do a stellar job in being able to identify what this material is. Okay? So we can use them, and we can use them to actually build, in some cases, a listing of intensive properties. Because, for example, why is this not clicking over? There we go. Intensive properties are used to be able to identify a substance, typically. Okay? So you can use extensive to get intensive sometimes. For example, we can take the mass and divide it by the volume, and what do we have? Density. Okay? And density is a really good thing to use to help identify different substances. And that's an intensive property. They tend to be much more unique to a particular substance. Okay? Intensive properties. States of matter. That is an intensive property. Melting point and boiling point. So water boils at 100 degrees Celsius. That doesn't matter whether I have a gram of water or 500 kilograms of water. The boiling point is still 100 degrees Celsius. Now, it's going to take more heat to get the 500 kilograms to boil. I'll give you that. But they're still going to boil at the same temperature. Okay? And the same for freezing and melting point. Okay? They're going to still freeze at 0 degrees Celsius. Density. Doesn't matter if I have a gram of water or 500 kilograms of water. The density of water is still 1 gram per milliliter. Just like when you did the density of water, you did it 6 different times in lab, you should have come up with the same value every time because the density didn't matter. You were changing the volume, you were changing the mass, but the density stayed the same every time. Do you remember that? Okay. Odor, what something smells like. Luster, so that means, is it shiny? Malleability means that you can pound it out into thin sheets like aluminum foil. You've probably seen aluminum foil before, right? Wrapped your potatoes in it when you make them, baked potatoes. Ductility means that it can be drawn out into thin wires like copper, for example. Copper wiring that is throughout this building, throughout your house. That's what they use for electricity. Texture, temperature, hardness, how hard something is, and then color. All of those are intensive properties. Okay. States of matter. Now, we talk in chemistry about 3 states of matter. There's more than 3 states of matter. Okay, and I realize that, but we're talking about kind of normal conditions here. And for us, we're not going to be dealing with Bose-Einstein condensates, which are really, really stupid low temperatures. And we don't have anything in this room that we can get up to a plasma level. Okay, so plasma, what they mean by that is like a really, really high temperature. They do have a plasma cutter in tech ed that if you take technology classes, you might be able to work with that. But here in chemistry, we don't. So we focus on just 3 states of matter in here, which are solid, liquid, and gas. And truly, these are the ones that you're going to be running into kind of in normal everyday life. So your solid then has a fixed volume and shape. So going back to my popsicle stick again, it has a fixed shape and volume. If we look at like water, for example, like Wendy's water bottle over here, if she takes that and tips it, or Malachi's water bottle, if he takes that and tips it, that water in there is going to change its shape. It's not going to change its volume. Its volume is going to remain the same unless he removes some of it by drinking it or adds more in. The volume is going to stay the same, but the shape of that container will dictate the shape of that liquid because it has the ability to flow. One of the other states of matter that has the ability to flow as well is called a gas. That does not have a fixed volume or shape. It will take up the volume that it's given. So for example, if you blow up a balloon and then you constrict part of that balloon, it'll change its volume based on what you've given it. It will also take up the shape of that. Now, collectively, liquids and gases are known as fluids. So even a gas is called a fluid in chemistry. Okay. Typically, you're used to hearing the drink plenty of fluids thing when you get sick, right? So what they're talking about there is liquids. They would be more precise in saying drink plenty of liquids. Okay. But those 2 things have the tendency to flow, so they are considered to be fluids. An additional vocabulary term for this chapter is something called vapor. So a vapor is the gas state of a substance that is normally a solid or a liquid at room temperature. So his water, in his water bottle there, water is normally considered a liquid at room temperature. When that evaporates, then it's considered to be a vapor. Or if you boil it, the the gas that comes off of that is considered to be a vapor. Come on. Why is this acting up? There we go. All right. So those are physical properties. Chemical properties then is the ability or inability of a substance to combine with or change into one or more substances. So ask yourself, is the material going to have the same chemical composition if we change it, if we go through this change? And if the answer is no, then that's a chemical property. So my popsicle stick again. If I set this on fire, am I still going to have wood in the end? No. Okay. So flammability would be the property. This has the ability to be flammable. Okay. As opposed to this paper clip, it is non-flammable. It's not going to catch on fire. Okay. It's metal. We might be able to get it hot enough to melt it, but it's not going to catch on fire. Okay. The ability to rust or corrode. So it's going to react with oxygen in the air typically, and that will cause it to either rust or corrode. The ability to explode. Explosions are chemical changes. And then the ability to form a precipitate. And that is not the same as like rain coming down, a precipitation. Okay. Let me see if I can find an example of that. Here is an example of what one of those precipitation reactions looks like. So they are going to be, there we go. Okay, we don't need the music. All right, come on, there we go. So they're adding in here lead, and that's in some, I guess they would have to tell us what it was. But can you see how this yellow substance is forming here? That is a solid. And if they let that sit for a while, it will actually show up at the bottom as a solid. It'll kind of collect at the bottom there. Oh, shoot. Why can't things just be easy? There we go. So did you see how they had two clear liquids here that they were adding together? And those two clear liquids then, there's the one and here's the other. When they react here, they form a solid in there, okay? And that's called a precipitation reaction. And we're actually going to do a couple of those in lab coming up. And we actually filter out the solid so you can see what the solid looks like. In addition to that, when we get into chapter 9 later this year, you will also be like predicting what it's going to form and whether it'll form a solid. And you learn how to do all of that stuff as we move through the year. Okay. So that is the precipitation reaction there. All right. Let's get back to our notes here. And I think we're about done. Yeah, because then we move into physical and chemical changes. And is that, I think that's tomorrow's discussion. So, so that's the notes for today.